So a lot of the times, what happens when people can't find themselves progressing in science and math, specifically the chemical and physical sciences, is their lack of confidence or inability to do algebra properly and quite quickly. And the center of algebra is to do something called inverse operations. And when we say inverse operations, we're talking about when a variable or a number is brought to the other side of the equation. It doesn't matter if it's the left side or the right side. Its operation is inversed. And what that means is if on one side of the equation it's being multiplied with another variable, if I bring that to the other side of the equation, it becomes divided by. What that means is that if one variable on the side is undergoing multiplication, then when you bring it to the other side, it undergoes division, and at the same time, if something is being divided, you bring it to the other side, it gets multiplied. And the same is true with addition, where it becomes subtracted on the other side, and subtracted becomes added. But more specifically, what people often forget is the squares and the square root. So let's say I have x squared, and I bring it to the other side, or to remove the squared, it would be root x. So if I square root the squared, then that is an inverse operation. Same as if I cube root. So if I have a cube, then I can cube root, which means that I'll have an index of 3 outside the radical sign, or outside the root, and then the x underneath. So these are inverse operations of each other. Let's take a look at a couple of examples and see how this translates. So in this example, when I want to solve for x and y is equal to m times x, remember that in math, when things are beside each other, that means multiply. So what I want to do is, when I isolate for x, I want to move everything that is not x to the other side. So I'm going to take the m and put it here. Well, we have to use inverse operations. In this case, since m is being multiplied by x, in order to move it to the other side, the inverse operation would be to divide it by m. So I'm going to divide both sides by m in order to cancel on this side. But what I do to one side, I must do to the other side. And so that would leave me with y over m equals x. In this equation, where y is equal to x minus m, again, I want to solve for x, which means I'm removing anything that isn't x to the other side. This is a minus m over here, so the inverse operation would be to add it. So I will add m to both sides. Minus m plus m would give you 0m. And my final equation would be y plus m equals x. Let's say in this equation I have y is equal to x over m. Well, in this case, again, I want to move everything that is not x over to the other side. The m is undergoing a division operation. So what I'm going to do is multiply both sides by m. That would make these m's cancel over here, and then I am left with m times y is equal to x. Now, what happens if I have more than one variable to move to the other side? Well, you're still going to do operations or inverse operations to each variable. You just have to do them one at a time. So in this case, I have y is equal to m plus x over b. I have to move the b and the m. Well, what I'm going to do is I'm going to move one at a time, and I always like to remove the fraction first. I'm going to get rid of that b. Now, b is undergoing division right now. So in order to remove it and place on the other side, we're going to use an inverse operation of multiplication. That would cause these to cancel, and I would be left with b times y is equal to m plus x. Now, here, this m, in front of it, there's always an invisible plus if there's nothing written there. So it's undergoing an addition operation, essentially. So if I move this to the other side, it's going to have to do the inverse operation. So plus m, in order to remove m on both sides, I'm going to subtract m. And that would get rid of this m over here. And so I'd be left with b times y minus m, and that equals x. And that would be the two-step algebraic problem over here.
Okay, so for the last one here, again, we have, or I should say second last one, because we'll do one more with an exponent. We have to do a couple of moves. What I do when I have more than one term as a denominator, I put a bracket around it so that I can easily multiply the entire denominator on both sides to get rid of it. So in this case, I would multiply bracket c by this a. And by putting brackets around this, it doesn't change the values. It just changes the way that we're expressing that denominator. So we multiply both sides by c minus a. That cancels this over here. And then what we have on this side now is c by this a bracket multiplied by y equals mx plus b. Now what I'm going to do is, I could do this in any order really, as long as I do it properly. I'll move the b to the other side. Since there's a plus here, we're going to subtract both sides by b. And then that gives us c by this a multiplied by y minus b is equal to mx. And then finally, divide both sides by m, and that would be this entire side over here by m. And then our final formula would read c minus a multiplied by y minus b over m equals x. And that would be the final solution for this expression here. So here when we're solving for x, we have x squared at the bottom as a denominator. And so that alone has some different rules. We can't just cross multiply this over here and make it y divided by m times a, because since this is a denominator, what you end up actually having is a 1 over x squared. And we don't want 1 over x squared, we just want x squared. So what we're going to do instead is we're going to bring everything else that we know over. Or, sorry, I would say let's bring this over to here so that we can just bring the y over, and x squared then ends up being isolated. So we're going to multiply both sides by x squared with the intention of eventually solving for it. Okay, that'll cancel this. Now I got x squared times y equals m times a. And then I'm going to divide both sides by y. And that's going to give me x squared equals m times a divided by y. And then now, remember that one of the inverse operations of an exponent is to root. Okay, and whatever this exponent is going to determine what kind of root we use. In this case, because it's a square, we're going to square root both sides. And then that's going to give us x is equal to square root m times a over y.